It's not a problem for me. My iPhone's always connected, except for when it's not.
When I pull out of my bat cave and launch through the waterfall, I lose connectivity there.
Hey everybody, and welcome to episode 44 of the iPhreaks show. This week on our panel we have Ben Sherman.
Hello from Houston.
James Zuber.
Hello from Minneapolis.
I'm Charles Max Wood from DevChat.tv, and this week we have a special guest, and that is Peter Kananen.
Hi from Cincinnati, Ohio.
Since you haven't been on the show before, Peter, do you want to introduce yourself?
Yeah, my name is Peter Kananen, and I have been a developer for about 8 years. I'm actually, we call it a project guide. I guess that's the less offensive version of a project manager these days at our company. I work at a small consulting company called Gaslight, and we have made our name mostly on Ruby on Rails work, although we've done iOS apps and we've done quite a bit of rich client JavaScript development the last few years. We tend to work with medium-sized companies, helping them build applications that build their business. And I've been doing iOS for about 4 years, maybe 5 now, I guess. Started in 2009-ish. So good time doing that. And I've been a little less involved in the last year with actual development time, but I've been trying to keep up with iOS. And the last big application I did was really relevant for the topic of today, which is offline authentication. So
awesome. So what do you mean by offline authentication? I have like 3 different guesses, and I want to see which one's right.
Okay, so the requirement that we dealt with is actually a project full of cliches, because we were actually building a literal bug tracker for literal usage in the field. And in this environment where we were collecting a lot of data, this is for an agricultural application. In the environment where we're collecting a lot of data, self-service is not an assumption that you can make out in the field, literally in the middle of nowhere, or at least South Dakota or something like that. And the need to record a lot of data offline and possibly allow multiple users to use the application, we essentially needed a way to keep track of user credentials when you're disconnected from the network, and then sync back up later with, the server-side application that we were interfacing with, which is the Rails app that we wrote as well. So for us, offline authentication meant that a user entered their username and password, and they were able to use the application with their previously stored data that they pulled down from the server, and they would be able to pass the device between users. Meanwhile, they were never connected to the network doing all of these things.
That sounds pretty handy.
So if they're entirely offline and they've never downloaded data, can they still use it, or do they have to have at least logged in once?
Yeah, they're going to have logged in at least once to pull down their data, because the application didn't really ship with any user-specific data. I suppose there could be some functionality that we could expose without an account, but for the client, that wasn't really a need, because they have an established base of customers. This isn't an app that you'd download from the App Store and just start playing with. You wouldn't have downloaded unless you had a long-term relationship with the provider. So.
Okay, so there's no chance of you sort of entering a username and password, and then we just hope it's okay for now, and then later on we'll check it again on connectivity? Right,
no,
so that you just kind of assume that their account is still valid?
Yeah. Well, that's one of the big questions, right, is how long should they be able to be offline before we require them to revalidate? Because what if their permissions change, or they're no longer a valid user, or those are the kinds of questions that make solving this problem difficult. So
what do? Do you store their username and password when they log in some kind of encrypted file?
That's usually what we did. Is initially, assuming we have a network connection, we would first attempt to retrieve their stored credentials, and we use the keychain for this in iOS, which is usually the best way to go about doing something like this. And this is another decision point. Do we attempt to re-authenticate and possibly pull updates for their account, user-specific data, or do we just assume what they have cached on the device is good enough for now, and there's no need to, revalidate? Obviously, if you don't have a network connection, you can't try to revalidate their credentials and pull down any data. But the decision to do that is kind of a tough one. And in some ways, you want the user to be able to, override the default and maybe pull down data as they desire, because maybe they know that they're going to get an update, even though the system might not be aware of that. There's, various strategies you can use in your server, in your application on the server to, deal with invalidated data. Use a last modified since value that you can provide. You can set various headers to show that your cache is invalid and stuff like that. So the happy path would usually be, okay, the user logs in, they pull down data, and let's assume they're going to be offline for a week. No problem. They can just use that data. Everything is stored locally in core data as they, create additional reports, which is what the user was doing here. And then when we find that we have an internet connection, we just go back and send up any data they created and then pull for any updates that they may need. So the edge cases there are what makes this topic tricky, in my opinion, because aside from the happy path is not that hard.
So walk us through kind of the application. So you've logged in, you've downloaded your data, you're all good.
Okay.
Now you're in a cornfield somewhere in the middle of South Dakota. Well, how does the app work?
Let's say you have data about a field, which is geographic data, coordinates essentially, and you might have some metadata about what crop type is there and maybe historical data about past observations. Okay, because this is like a scouting app essentially for agricultural usage. And you go and create a report, you walk the perimeter of the field, the device is recording your coordinates, which since we're using an iPad in this case that has GPS hardware, you don't need to be connected to the network in order to record any of this information. And then, we're just, as the user takes pictures or makes notes about things, we're just creating a model that's saved in core data of all their observations relative to that field. And then when they go back to the server, they get back on a network connection, they can choose to submit the report that they've created. And that's essentially the use case for the app. It's not extremely complicated in a lot of ways, but it gets tricky when you deal with data that's being pulled from the server that has several different layers of nesting. So you might have like a regional level of data, and then you have a grower specific level of data, and then you have fields underneath that grower. So you have this network essentially of this data that needs to be all pulled down together because the relationship between these entities is really important. And the data size in these cases wasn't huge, but once you throw a couple thousand objects in core data and start mapping them, it can be a little more interesting there. And choosing how to update that data is kind of hard. You can attempt to do deltas, but if an object at the lowest level is dependent on, another object there, like in a kind of like a has-many relationship or something, and that object in the middle goes away, then you have to blow away essentially all of your local data. And there's different, merge strategies you can employ here, but we chose usually to go with if you want to do an update, we're just going to blow everything you have away and start from scratch. So,
okay, sounds like more of what you're discussing is not necessarily authentication, making sure that the right user is using it, but what to do after the user comes online. So you gathered all this data, walking around the cornfield. Now you're online. Was it more of a sync problem? Am I getting that right?
It is kind of a offline data sync strategy. And there are some really cool enhancements added to iOS in the last year or two that are supposed to help with this. Unfortunately, the time when I spent most of the time developing the app, it was still like really early for things like incremental store to be used. Yeah, so like you mentioned, the offline data to me was one of the harder issues. The authentication itself, really was just, we're going to store the token and then we're just going to use that token next time we get on the network and are able to submit information. So maybe the other panelists would have some, more unusual use cases for offline authentication and any issues they encountered. But I didn't have that many just with the authentication part. I did complicate my life a lot when I made a mistake in my server-side authentication logic, and I gave an invalid token to a number of users. And that actually turned out to be really tricky to get rid of the bad token on their device. And actually, there's almost like this concept of versioning that I've encountered when I was trying to implement this offline, authentication logic. And that might be a more interesting topic to talk about as well. So any other experiences on how you've solved this problem for, offline usage of an application for a user's account?
I have a similar anecdote. Yeah. And to go with it, sort of a hard lesson learned. One of the projects I worked on a few years ago, it would store a lot of data, GPS data, and then at the end of a trip, you would submit the data to the server. And we would do some number crunching on the server to basically analyze the trip. And it wasn't so bad for like my drive from home to work, and then I would like work on that data, and it would all work. And the idea was just like simple like Rails controller action. You would submit an array of waypoints and a name for the trip. And the server would save it into the database and compute the score and then return back the score to you and other things that we've determined based on the analysis of the trip. And so that worked fine. But it turns out that truck drivers started to use this app, and they would drive from like Florida to California, all tracking the data, and it would all go in one big file on disk. And so then when we went to go send it, that post would end up taking longer than, I think at the time, Heroku had a 30-second timeout for processing a web request. And we didn't do any of the stuff in the background at that time, which was, lesson learned number one. And because of that, some of them would actually get stuck in the processing phase after they had been saved in the database, but before we returned the result to the client. So the client, being smart and wanting to handle low network conditions, would just say, oh, we got an error. I'm going to submit that one again next time. And so we got just loads and loads of duplicate trips. And to make matters worse, the timestamps were based on when you submitted. And so it was not trivial for me to detect the fact that they were duplicate trips, especially since it would append onto the same file. So there was a number of problems there, but one of the biggest ones I think is to generate IDs on the client side so that I could detect whether or not you're trying to submit the same trip twice.
When you said that it would take more than 30 seconds, I thought you were going to say it would take longer than it took them to drive that distance.
Yeah, I mean, it's kind of a similar scenario where they're collecting a lot of data. We didn't want to hammer their network the entire trip. And so we were just collecting it into the end, and then we zip up that file and upload it. But then Rails has to do something with it. And, what we should have done is, accept the file and say, okay, we're processing it, and give them back like a token that they can go back and look at the trip, at the status of that trip. And then we could just process it in our own time and update the record when we're done, and they could just poll for the status.
So I'm kind of curious, if you have like multiple access levels, do you tend to manage all of that in your iOS app, or do you do some kind of management on the back end, the data service or whatever? Because it seems like you would need it in the case of, doing offline authentication especially, or even just making the application responsive enough, given that the data is already there on the application. Does that change any of the parameters of your offline authentication?
I suppose it could. I didn't have many very levels of user permissions. Everything was essentially controlled via the data that they had access to. So that was definitely one challenge. Let's say that the user has access to a certain set of data. They pull that data down on their device. They are offline. Meanwhile, they lose access to that data server side, and they no longer have that account permission. And there's a much more robust permissioning system on the server side app, in this case, a Rails app. And then later the user creates data based on this invalid data they don't have access to anymore. Let's say it's an account that they no longer are working on. And then they submit a report for that account. Well, the server is going to have to check to make sure that they no longer, make sure they have access to that. And oftentimes that kind of permissioning wouldn't be built into, your Rails controller that you would use if you're just serving up a Rails view, because the assumption is, I'm always going to have access to data because I'm running, just browser request response cycles here. And it's not like I'm going to lose access to the stuff on that 30-second timeline like I would, if I'm offline for 2 weeks. So most of my user permissioning was really at a data level. It wasn't directly controlled.
I think it's really important to make sure that, it absolutely has to be on the server, right? It's like if somebody were to not use your client and use their own, homegrown one to hack your service, you still have to have that level of data security on the server. But like you said, you can't just check at any point in time, do I have access to X? So I think it also, in this case, needs to be on the client so that you can, if there were such a requirement, to say, okay, you can't edit this field. And let's say somehow, due to a bug in the software or a malicious user who can, jailbreak their device and go edit stuff in the application itself, once they go to submit that data, it should be able to validate that, yes, the data that you submitted is still valid. Like nothing was tampered with. Either that or we just reject the things that we're not allowing the user to write.
How do you keep those permissions in sync? It's a much easier question to ask, I think.
I don't know. I mean, in a lot of cases, you can just punt in web apps and say the server will catch it. For instance, like username uniqueness validator. Like almost every website will have a form. You type in your username, and then it's so easy to write an AJAX request that just checks the validity of that or uniqueness of that of that username, but then you also have to check again when you submit, right? So that one's like a quick win. And so it doesn't matter so much to keep that in sync. If the rule is more complex, I think it's perfectly acceptable to just punt and let the server handle it and return an error, right? But in an offline scenario where you're going to be disconnected for a period of time where you're not going to know if the data you're entering is invalid, I mean, think of the pain that might cause a user if they were supposed to be entering in values in Fahrenheit instead of Celsius or whatever. What do they do at the time when they're trying to submit all these reports? Do they have to go back and correct them right then and there? Like that to me seems like it's worthwhile for the user experience to keep them in sync manually.
Mm-hmm.
Yeah, this is one of the harder topics to address. And again, it's almost not as much of a technical challenge, although that can be the case. It's almost more of like a implementation. How much do I value this thing over this thing? And what is the user experience here? And do I want to lessen user experience and create a easier to implement permission system for validating this data? One thing that we did in a few cases is we attempted to use a hypermedia approach to the services we were talking to in the Rails end, where the response would indicate to the client the next actions that it could take, almost build a very primitive state machine into the HTTP responses. And that way, the client ideally should never be confused as to what actions it can take next. It takes a lot of work to build this correctly, but the idea is you don't want to end up in a situation where a user feels trapped on their device. They can't solve the problem that they're in, which might be data that goes missing that is no longer available for them to see. This happened to us when they would go to the server, pull down new data, they would lose access to some information or some objects or entities that are no longer valid for them. But data that they've created based on that old version of the data model is now lost because they don't have access to see it, and it's actually trapped on their device. This is a really unfortunate situation to be in. And that did happen to us. So those are the kinds of considerations you have to make.
So when you're talking about hypermedia, kind of walk us through exactly what's happening. You're talking about having your service actually be kind of they call it the engine of the application state. What does that mean for when we make a request? How is our response or our request different?
Well, first of all, I am not an expert in this stuff. I've just dabbled in it a little bit. But the idea is that the response you receive as a client should indicate to you what things you can do with the response. So, for example, it's going to include URLs that are relevant to the data you receive. I get a list back of all these things, and each of the entries includes a URL for showing them, like the show URL, the simple get, and then perhaps like how to post back or how to create. And the idea is that it's a more robust way to build a client-server relationship or any application that kind of has several different clients talking to it. And this could apply to a web app as well. If you've ever dealt with, multiple teams building different clients that interact with a central application or central services like a web service, these kinds of systems, when you build this support in from the beginning, makes it a lot easier it's almost like built-in versioning and intrinsic knowledge about what valid things you can do with the application.
That's very cool. So basically you're getting back a set of links to different URLs. So if you're trying to upload data and you no longer have access to that because you've moved on to a different project, one of your responses would be a different URL that might show you information saying you don't have this, error conditions. Yeah,
and like I said, I'm not an expert in this topic. I would recommend that you read about hypermedia and this idea of, I believe it's called Helios. And this is like using HTTP as the engine of application state and essentially treating HTTP as a API. And it's interesting. I wish I knew more about it. And I've used it in simple cases to, store and retrieve information about certain entities that a user might have access to editing. But I haven't built an entire application around these principles.
Okay. I've done some work kind of creating iOS, or creating a web service and done it with iOS. And I found it very powerful, at least for the application we were doing. We were doing kind of a search engine. So we, instead of returning just like a blind filter, we would return, here's this genre of music, here's this genre of music, here's something you can search next. So if you searched had a text string, we would also return, a URL for your next search. So it's kind of going into the weeds of hypermedia, but it's definitely doable for iOS and actually a very good way to write your APIs.
So how do you handle cases where, similar to the one I described, where a request maybe failed halfway throughout and the server may have received the data, but the client thinks it hasn't sent it yet, or maybe encountered an error?
Generally, you kind of becomes kind of your domain. So you have some workflow. You set down what actually happens in this kind of error case. And
so, if you think about an endpoint where you're going to add a new report, like submit a brand new report versus updating an existing report, those would be two different endpoints. So one's an insert and one's an update. And so if you continue to call the insert because you think it's brand new, you run into issues there, right?
Right. Yeah, I guess I don't fully understand. I think a lot of times it comes down to just fully fleshing out what happens in different error cases.
And so if there is one, maybe you just decide that those two endpoints are the same, like submitting a report is submitting a report, and it will either insert or update the existing report that's there. One of the techniques of generating IDs on the client side can help alleviate that, because then you would know that, hey, this one already exists.
I think the more restful way is you got your resource, your report, and you create it by creating a post, and you probably get back your ID, your URL for the new resource, whatever it is, and then you can do a put up to that. So the server would give you your ID, and then you would respond to a second request that actually uploads the data using a put that would go to that ID. Does that make sense?
It does. I think you could do that in one step, where you have, the server just does the check for you and says, okay, we've already inserted this one, so I'm just going to give you the location of the existing one. And from the client code, it doesn't matter if it was a brand new insert or it was already inserted, but you just didn't know about it, so I'm just going to give you a thumbs up, right?
It could be. If you're inserting data, how do you know it's repeat?
That's why I say you should generate an ID on the client side. Right? Did you do anything like that, Peter?
I'm trying to remember how we handled that. I know that because we were creating core data objects, we were using RESTKit, which helped most of these mapping problems. And there's a way to, when you receive responses back from your RESTful service, to tell RESTKit how to map attributes you get back to values in core data so it doesn't recreate them essentially. So how does it know if it's a duplicate versus a new one, or an existing one or a new one, a new entity or existing entity in core data? Well, RESTKit helps you do that with I think there's like a identifier property or something that you set. I don't think we generated client-side IDs that we would use in Rails, although you do have a core data ID, and there might be some logical key that you can, like a computed key almost, to know how to say, okay, I have this particular object for this parent record and on this day, so that should be mapped to this. And I think that's how we did it, but I could be wrong.
I'm a fan of using natural keys where they're like truly, truly unique and always present, but turns out those are kind of hard to come by. Like, somebody might say, like, oh, we'll just use social security number. Turns out that not everybody has one of those, And so...
and they're typed wrong.
Yeah. So, I am a fan
ones.
of using like logical or natural keys, when you can get away with it, for sure, rather than relying on a GUID or something. But yeah, I think, using some sort of key like that, at least it saves your app from inserting the same data twice.
Yeah, if there's some client-specific key, it kind of weirds me out to have a client create the key that the server uses as its unique key, but if the client had its own specific field, that you can make sure that you're not having duplicate data. I think that's reasonable.
Yeah, it doesn't have to be the primary key on the server. It's just a field that is unique in the database, and the client generates it, so that way you can easily check. What about, I don't know if this was a case for you, Peter, but if you allowed this to exist on multiple devices at once, are they editing the same reports? Are they creating new reports? Is that report maybe tied specifically to that device? If you could edit them on different devices, then you run into the problem of, conflicts arising when you finally get back to the office to sync up.
So thankfully, once you submitted a report from your device and it was received by Rails, no more edits could be done on the device for that. That greatly simplified that particular workflow. So you really can have a report in progress by more than one user, and that report, it's only local to that device. Once it's off the device, then it's no longer editable. That saved us a lot of work, because that's a hard problem to solve. I would be really interested to know if someone has experience with Incremental Store out in the wild to see how that's holding up in a production environment. Because when I was evaluating it for usage on this project, it was like, oh, it doesn't do, several of the major CRUD operations yet, which obviously was a deal breaker for me. So
Yeah, I've only played with it, similar, just evaluating it. While it's technically really cool, there was a whole lot of magic that I didn't understand. And a lot of times that's the stuff you need to understand in order to fully extend it to accommodate your use cases. So I haven't ever used it in production.
Okay. Yeah, I'm interested to check back in on that one because it seemed like NS Incremental Store really was designed to solve a lot of these hard problems. And other frameworks like RESTKit with the core data support, they got you close to there, but it's hard to piece together information that is, possibly incomplete and possibly in conflict, and to keep that in sync across core data on, multiple, possibly thousands of iOS devices, some of which are not online all the time, and, your central database. That's a hard problem to solve. So
I did see Jonathan Penn's NS Incremental Store presentation at CocoaConf, which was fascinating and kind of terrifying at the same time. His use of it was mostly, I think, to demonstrate what you could do with it. And in his case, he was storing, lots of P lists for the records. And so it's kind of like deconstructing NS Incremental Store and learning a whole bunch of stuff about core data along the way that you probably never wanted to know. So it's definitely like a, technically cool topic. It certainly requires the requisite amount of like investigation and, prototyping to make sure that it does work for your use case.
So if it's okay, I'm going to back up a second and talk a little bit about the keychain and its role in this. I kind of oversimplified it because it's not usually that hard to deal with. So Keychain Services is provided by Apple for usage in OS 10 and iOS apps. I've never used it in OS 10, although I understand almost all of us have used it. And there's like a master key that, allows you to essentially access a bunch of stored passwords or other tokens and things like that. In iOS, each app has access to its keychain without the need to unlock anything. This is really just because iOS supports app sandboxing and it actually requires it. So you don't even need to enter a password for an app to access the keychain. I think Keychain Services is a C API. I've never actually interfaced with it itself. I've always used a wrapper, and I've used the one that used to be called SFH Keychain Utils, and now it's ST Keychain, which is part of ST Utils by LD Anderson on GitHub. And that provides like an easy way to store items in the keychain, and you can associate them with like a username and a service name, I believe. So you could potentially store a couple different values for a user. And what I ended up doing was I created a category that essentially made up, like, I used this system of creating service names based on particular needs. So if I needed tokens for more than one service, I would just create a different service name for those things and then name the category method appropriately. I also used these service names that this framework, this little library supported to essentially invalidate offline data. And I suppose you could lock some of this out at the server-side level, but let's say a user has a token that they've received from the web service that provides them access. Well, in my case, I ended up with a situation where users had a valid token. The only problem was it was not their token. And it was really hard to figure out how to make them stop submitting reports as the wrong user, because I'd never built into the
That sounds
iOS
really
app.
bad.
Yeah, it is really bad. And like, I can't put logic in my controller to say, oh, if you're this user, really set your username to this because, it could be the valid person doing this. It really all came down to a bug in my, finder create user by method and making assumptions there that were incorrect. So what I had to do was when I shipped the next version of the app, I created another version on my service name so that I wouldn't try to pull the wrong token anymore out of the keychain. And I should have dug into the keychain more because I didn't find a lot of good support for deleting values. You can remove them. I think you can remove for a username or for a service name, but I know there was some limitation with the library that I was using to do that. So I ended up creating a version of the service name essentially so I could store these credentials, and invalidate them accordingly. So if anyone has any thoughts on how Keychain works and what best practices you should use, I'd love to hear them.
I've used a lot of the, similar auth token type API access where you store a username and password in the keychain and a temporary auth token. And the idea is that auth token is a potentially vulnerable piece of data where if somebody gets a hold of it, they can impersonate you forever. And so I like to make my auth tokens expire, kind of like every once in a while your credit card company sends you a new credit card, so that if one ever gets out, you sort of limit the ability for that to cause problems. In addition, you can at any point in time just cycle somebody's auth token, and hopefully their experience doesn't suck when they try to submit some data. The way I've handled that in the past is when they type in their username and password, I save that in the keychain also. But in transit, obviously you're only sending the auth token for authenticated requests. And if I ever get back a auth token, expired or invalid call from an API request, it'll be like, 401 unauthorized or something. And I'll inspect that. And if it's the one that I'm looking for, then I will hang on to that request and instead make a login call for a new auth token using the saved login credentials and get back a new auth token. And once I have the new auth token, I'll save it and retry the original request. So the idea is that the user doesn't really know this is going on. And if that login request fails, then of course, at that point, something bad has happened, right? And that user probably doesn't have access anymore. So if I'm not going to continually try to re-log in. I'm just going to try that once. But if it does work and I get a new auth token, then I can retry that original request and do that without the user having to push the button again, which I think is a really good user experience, and it provides a decent level of security and the ability to revoke auth tokens without adversely affecting the user experience.
That's actually really similar to the workflow that we used as well, where we would have the username and password stored and a token, and if their token expired or some other problem occurred and maybe validation on the server, then we could attempt to log in for them and acquire a new token and resubmit data. And hopefully all they see is just a little bit of, spinner activity while all this is happening.
So I have a question, and that is, if you're offline for a long time, sometimes the app gets out of date. Do you wind up having to maintain some backward compatibility both in your API and possibly your database schema on the back end in order to accommodate that?
Man, that's the bane of my existence. I don't even think that really has to do with necessarily offline apps. I think people in general just, if they're not on iOS 7 or they haven't updated their, the automatic updates feature, we still have plenty of requests that happen to our old versions of the API. And as we want to make changes and improve things and, right previous wrongs and things, it becomes somewhat annoying because you have to still accept all of the bad data that you used to get, or not bad, but in a different format, and then handle it in the new way if it's in the new format.
Yeah, the concept of data migrations was frequently discussed around here. And coming from Rails to core data, it's not quite as simple as it was in Rails to do migrations, although it's possible, and Apple does provide support for it. It's just usually not as seamless in my experience.
Yeah, I mean, if you add a new column or a new attribute to an entity or add a new entity, those things are usually fine. If you change the type of a column, then I think you're kind of hosed is not the right word, but
I think at that point, time.
Yeah, you can have a bad time. You have to create, the new model, in the standard way, and then connect to the old model and copy the data over to the new model, then delete the old model and rename that one back to the original file name or whatever. I'm not sure exactly how those migrations go, but
I think the official term is data gymnastics.
Yeah.
So, anything else that we should bring up before we get to the picks?
I think we've just skimmed over 5 episodes worth of stuff.
Yeah, it's kind of
offline authentication, sync, hypermedia, core data migration.
Yeah.
Those are some of the harder problems, though, is trying to figure out the answers to these things. And oftentimes it involved discussions with the client, like how much do you value someone being able to just pull their updates for, do the delta and get the 3 things that have changed versus sitting there for 5 minutes and loading in thousands of, we were loading a lot of wicket data, which is, this well-known text representation of geometric shapes for plotting on maps. And we were like, how much do you value sitting there for 5 minutes waiting for it to load versus being able to get the 3 things that have actually changed? Because it'd be a lot easier to just pretend it all changed and just download it all. So it required a lot of, user experience thought and what's the value of implementing this feature versus the amount of work it takes and the complexity that it adds. Because this topic, when it was first discussed as a feature, we're like, oh, it's not that hard. We'll just keep everything in core data like it is. And then we'll just have to check for, this one thing that may have changed when they get back online. Then turns out there's all these edge cases you need to assume or need to consider when you're building this. So it's a nuanced topic, and that it touches a lot of other functional areas of the application.
All right, well, let's get to the picks. Ben, do you want to start us off with the picks?
Sure. We've got 4 picks today. 2 of them are games. I have been losing lots of time to this game called Threes. It is an insanely addicting puzzle game. You've probably already heard of it, and maybe you've already played it, where you combine tiles of given numbers together. So you can only combine a 1 and a 2 to make a 3. And from that point on, a 3 has to merge with another 3. A 6 has to merge with another 6. And the idea is the whole board moves at a time, so you can go up, down, left, or right, and the tiles all move together. And so you want to collapse things in groups if you can. And the scoring is sort of exponential as well. So the higher numbers you get, the way higher the score goes. So anyway, it's really addicting, and I kind of suck at this game, but it's fun. So check out Threes. Another game I've been playing recently is Hearthstone. It's a game by Blizzard that uses the World of Warcraft lore, and it's kind of a fun interactive card game. It's right now it's free during their open beta, and this is eventually going to be an iPad app, and it's just a lot of fun. I've been having a lot of fun with that. Another one related to the topic today is Stuart Gledow's talk this was at CocoConf in Boston, I believe. No App is an Island. And in it, he talks a lot about the, REST style, hypermedia design of APIs for the purposes of consumption in a mobile device in order to, make the mobile device a little bit more robust to changes and not so tightly coupled to implementation details of the server. And my last pick is a beer pick. I had one from Utah, actually. It's Detour Double IPA by Crooked Line, I believe is the name. Anyway, it was super potent and very tasty. So I will put a link to all of those in the show notes.
Awesome. James, what are your picks?
All right, I'm going to go with 2 picks. Since we kind of skipped over the Hypermedia stuff, I just want to point out a couple resources that really helped me when I was trying to figure this stuff out. One is a book called Restful Web Services. And it's pretty old, I think 2007, something like that. But it's really one of the earlier lengthy descriptions of how to write hypermedia, what REST is, how to use resource base, how to do hypermedia. It's by Sam Ruby and Leonard Richardson, but it's really a solid book. I've gone through it. It took me, I think, twice through before I actually started absorbing the content. But people are looking to kind of move beyond kind of simple web service design. It's a really great resource. And secondly, a more recent thing, if you've drank the Kool-Aid, the REST Kool-Aid, and you're like, how do I create a hypermedia API? There is a specification called HAL. I don't actually remember what it's called, or it stands for HAL, Hypertext Application Language. It's very simple. Most of the languages you're probably thinking of using have a library for it, but it's actually fairly simple. You would be able to write your own kind of library, but just a basic way to organize your responses into links, resources, and things like that. So I'll recommend HAL. Those are my picks.
Awesome. I've got a couple of picks also relating to hypermedia APIs. Steve Klabnik, he's a fairly well-known Rubyist, but he has a book out on designing hypermedia APIs, and that's at designinghypermediaapis.com, and that'll be in the show notes. Also, we did an episode with him 2 years ago, back when hypermedia and REST were kind of defining themselves as different from each other. And so that one's called REST Done Right. It's on rubyrogues.com. I'll put a link to that in the show notes as well. We're also going to be interviewing Steve in a few weeks on the JavaScript Jabber show, and so you can get updated information on what hypermedia is and what it means there. And finally, I almost finished this basic economics book. It's by Thomas Sowell, and it's an awesome book. I've been listening to it on Audible, and the narrator's pretty good. But if you want to get a real handle on how things work at large in the economy and what some of the incentives are for people to do certain things and why politicians on both sides of the aisle are wrong and in a lot of cases are really just doing what will get them reelected as opposed to what will really help us out, then I highly, highly recommend this book. And so I'll put a link to that in the show notes as well. Peter, what are your picks?
Well, first of all, I also have been listening to Basic Economics over the last 6 months or so, and it really did kind of pull back the wool a little bit on the idea of unintended consequences of, what sounds good in theory can have the opposite effect in practice. So really interesting stuff. My sole pick is SmartThings. SmartThings is a home automation platform, I guess. I think it started from a Kickstarter campaign a couple of years ago and has since, launched as a platform that is, I found to be very developer friendly. And you can buy a hub for $99. And right out of the box, you buy the hub and any of your iOS and I assume Android devices, you can register those as proximity sensors for the hub. So, you can buy one for your office and you can see, you log into SmartThings, you install the app and you can see right there, like who's in the office, who's not. And then you just start adding sensors. It's compatible with most of the Z-Wave and Zigbee sensors, and anything that goes on Wi-Fi will work on it too. Not anything, but most things are. So you start adding motion sensors and switches and dimmers and, garage door openers, and you can add cameras and motion sensors or the accelerometers, and you can start to automate your house or your office. And it's a really clean interface. It's really friendly for, us people who want to write code and build things. One nice thing about it too is it's a little bit on the opposite end of the spectrum from, buying an Arduino and wiring up the sensors yourself. Once you've done that once or twice and you've realized how much work it is to actually build something that's really complex, you'll really appreciate what something like SmartThings does for you. And they do have an IDE. It's like a web-based IDE, and you can publish they call them smart apps that you can kind of plug and play these devices and wire them up to do all kinds of cool stuff. It also works with if this, then that. So I think it's really fun to jump into that stuff. I've started to do it with my house, and I would highly recommend SmartThings.
No, it's very cool tech. Those are Minneapolis guys that did a lot of the tech stuff for that. So
yep,
it's very, very cool.
Minneapolis makes everything cool, doesn't it?
It does. It's so cold here. You got to stay inside and build stuff.
I was actually born in Minneapolis, so I guess I'd agree.
There we go.
There you go. All right. Well, we'll go ahead and wrap this up. Thanks for coming, Peter.
Yeah, it was great to be here.
Yeah, thanks.
We'll catch you all next week.